Let's continue our journey with the graphs of derivatives. Start with this problem. The graph of the derivative is shown below. You're given the point 0, 3.5. Find the absolute maximum of f of x. So let's just take a look at what this graph might look like, the graph of f of x. Notice that the first derivative here is given. The y-coordinates of every point on the first derivative from 0 to 8 is positive. So that means that the f of x graph is increasing. If the first derivative is positive, the position function is increasing. So from 0 to 8, this function is increasing the entire time. Now let's look at the slopes of the tangent lines of this graph. If we talk slope of the derivative graph, that means we're talking about the second derivative. So anywhere where the slopes are positive here is where the second derivative is positive. Anywhere where the slopes are negative, it's the second derivative negative, and that tells us about concavity. So when x equals 0, the first derivative equals 0. So there's a horizontal tangent line there. And then from 0 to 1, remember the graph is increasing forever, but because the slope of this line is positive, that means that the second derivative is positive. So we've got something that looks like concave up. When we get to 1, the slope actually is flat from 1 to 3. From 1 to 3, the slope is constant. A constant slope is a line. The slope of our derivative graph, the slope of our tangent line here, is actually equal to 2. So if we draw the original graph, the slope of the tangent line is 2 from 0 to 1. So that looks like a line, changing my color to make a line. Now, once we get to 3, and notice that's really not concave up or concave down, like that's a line, so it can't be concave up. However, from 3 to 4, the slope of this line is increasing again, so that means that the tangent line of the first derivative is positive. That tells us that the slope of the derivative graph is positive. So that means the second derivative is positive. We've got another concave up situation again. So from 3 to 4, we're concave up again. But again, notice that when x equals 4, the slope is constant again. Constant until we get to 6. And this time the slope is equal to 3. So we have another linear situation. The slope is a little steeper this time until we get to 6. I'm running into the graph above, just ignore that. Okay, so now once we get to 6, we're still increasing because the value of the derivative is positive still, but now notice the slope of the tangent line. The slope of the derivative graph is decreasing now, so that means the second derivative is negative. That means we're concave down. And we're going to approach concave down. We're going to get the slope is getting smaller, like the value of the slope. So the tangent lines are getting flatter, and then when x equals 8, there's going to be a horizontal tangent line. So it's going to look something like this and be flat right here. So here's f of 8. I'm off a little bit. Okay, so there's our picture of what f of x might look like. So the question is asking, what's the absolute maximum? Well, if you notice, we really didn't need to graph this. I just wanted to show you the concavity again, but if this is a forever increasing graph, and we know that because the first derivative is positive, well, the absolute maximum has to occur when x equals 8. So f of 8 is going to be the absolute maximum point because f of x is increasing from 0 to 8. And f of 0 is the lowest point. So if you know that f of 0 is 3.5, we need to figure out the distance traveled from 0 to 8 so we can figure out the y-coordinate at x equals 8 because that's the maximum value. We have a starting point. We actually know what the starting point is. So if I go back to this picture that we had, this is our f of 0 point. This is equal to 3.5. So if we can figure out the distance traveled from here to here, we can figure out our y-coordinate. Okay, so that's what integration is for. because if you want to know distance traveled, you have to integrate the derivative equation. We don't have the derivative equation, but we do have the graph, and integrals are area under curves. So we just need to find the area under this curve. All right, distance traveled represents the area under the curve. So this picture, it would really be easiest if we could just draw a horizontal line here and make two trapezoids out of this. But I don't really know what this point is. We can't assume anything. So it's easier to just draw two vertical lines. And now we have three trapezoids. Area of a trapezoid is the 1/2 times the base. The base is always where the perpendicular is. So for this case, the base is this amount. I'm sorry, I'm saying base, I mean height. Height. This is the height. So in this case, the height is 2, and the bases are the two pieces that connect to the right angles. So this base is 3, this base is 2, and the height is 2. This trapezoid, the height is right here actually, because that's where the right angles are, and then the two bases are 2 and 3. And for this one, the height is right here, that's where the right angles are, and this base is from 4 to 6, so that is a distance of 2. This base is from 4 to 8, that's a distance of 4. So you set up just simple geometric formulas to get the area of each one. This is 5. This one ends up being 5/2. This one ends up being 9. This is 18 divided by 2. So the distance traveled from 0 to 8, because we found the area under the curve from 0 to 8, 16.5 units. Okay, and if we know that the distance traveled was 16.5 units, and we know that the starting point was 3.5, like the point, oh, this is a horrible picture because it should, anyway, it should be on the y-axis. But we know that this is 3.5, and it went 16.5 units. You would just have to add. You would take the 3.5 that you started with, knowing that the absolute maximum when x equals 8, or occurs when x equals 8, you would just have to add the total distance. So this is going to equal 20. So it's important to know, just based on the picture, if you have an increasing or decreasing function, and then if they've given you a point that's lower than what you started with, then you're going to have to add what the distance traveled is to the point you start with. Okay, let's do another one. Okay, so this is another increasing function. Notice that the derivative is positive forever. It has a few horizontal tangents, but it never dips below the x-axis here. So the first derivative is never negative, which means that if the first derivative is never negative, it's never decreasing. This graph is always positive, which means that the f of x function is increasing forever. Well, from 0 to 4. And now we're given f of 4 this time and asked to find the minimum. So if we know that this is increasing the entire time, then f of 0 is going to be the minimum and f of 4 is going to be the maximum. So let's just draw another sketch of this just for the sake of practicing sketching derivatives or f of x functions from the derivative. So again, we're increasing forever. There's a horizontal tangent here. There's a horizontal tangent here. There's a horizontal tangent here. There's no extrema though. And if we talk about concavity, it means we're going to talk about the slope of this graph. So the slope of this graph is positive. It's going to be concave up, concave down, concave up, concave down. Now notice the second derivative does not exist here. Second derivative does not exist here because you can't have a tangent line at a point like this. So something weird is going on. However, the concavity does change. It goes from a slope that's positive to a slope that's negative. Therefore, we go from concave up to concave down right here when we get to x equals 1 and x equals 3. But the derivative does not exist. So we'll get to that. Let's draw a picture. So we are increasing and concave up. Notice that it equals 0 here, the first derivative, so we're flat again right here. And then we're concave up until we get to 1. And then at x equals 1, the derivative does not exist, which could very well be a vertical tangent line, because then it changes to concave down. We're going to stay concave down until we get to x equals 2, where there's another horizontal tangent line. However, there's not a maximum here. It goes back to concave up again because the slope is positive again. So there's a horizontal tangent there, but now it's concave up again. And again, the same thing happens. We probably have a vertical tangent line right here when x equals 3 because of this point, because the concavity changes again and it looks concave down again. I'm off a little bit. But now at x equals 4, the derivative is 0, so it's flat there. So this would be our f of 4 point. This would be our f of 0 point. So again, the absolute minimum is going to happen here. F of 4 is our highest point, and this equals 7. So once we can figure out the distance traveled, distance here and here, and these are just two triangles, we can find the area underneath those, no problem. Once you can figure out the distance traveled between 0 and 4, you'll know how far this thing traveled on the y-axis. And then because this value is the highest point, if you know the total distance between 0 and 4, and this is the highest point, we're going to subtract this time. So f of 0 is going to be the absolute minimum because we're increasing the entire time. We know that f of 4 equals 7, so the distance traveled from 0 to 4, we just need to figure that out. And the distance traveled will be the area under this graph. So we've got two triangles, the base is 2, the height is 2, so 1/2 base times height, these are identical. The area is, these two's cancel, the area of this is 2, the area of this is 2. Total distance is 4. Total distance is 4. So if we know the total distance from here to here is 4, now we're talking vertically on the y-axis. If this is at 7 on the y-axis and we traveled 4 spaces, this is going to have to be 3. So therefore, f of 0 equals 3. This all comes from knowing that the picture that we're looking at is a forever increasing function because the derivative is positive. The first derivative is positive the whole time. The highest point on this function is going to be at 4 just because it's increasing the entire time from 0 to 4. So if this is the highest point, f of 0 is going to have to be the lowest point because it's increasing the whole time. This is going to be the absolute minimum. If you know the distance that this particle traveled, or whatever we're talking about traveled, is 4, you're going to take this y coordinate and subtract the distance to get our absolute minimum of 3.